So in number 7, the secant of pi over 2 minus x equals negative 3/5. And that's a cofunction identity. If we look at our trig hexagon off to the side here, we have tangent sine divided by cosine. Back a little bit. Then this is cotangent, cosecant, secant, and a 1 in the middle. And our cofunction identities go horizontal, left, and right. So the secant, its cofunction is cosecant. So we could replace this with cosecant of x equals negative 3/5. And cosecant is the reciprocal of the sine. So this would mean that the sine is equal to negative 5/3 if we just flip our cosecant over to get its reciprocal. So sine is negative. Tangent, we're told, is less than 0. And the quadrants acronym, all students take calculus. A means all are positive in quadrant 1. S, sine, and its reciprocal cosecant are positive in quadrant 2. T, tangent, and its reciprocal cotangent are positive in quadrant 3. And then cosine and its reciprocal secant are positive in quadrant 4. We're looking for the quadrant where the sine is negative, which would be either 3 or 4. And we want the tangent also to be negative. Tangent is negative in quadrant 2 and in quadrant 4. So the quadrant where both of those are true, the sine is negative and the tangent is negative, is a quadrant 4 angle. Okay, then number 8, secant equals tangent times cosecant. When you look at your trig hexagon, tangent is here, cosecant is here, and they make a hinge with the vertex at secant. And those are product identities that make hinges. So the product of tangent times cosecant is the secant. Similarly, tangent times cosine equals sine because they make a hinge. Cosine times cosecant is equal to cotangent. They make a hinge. So this is one of the product identities. Another example of that type of identity would be sine is equal to tangent times cosine. So tangent of x times cosine of x is equal to the sine of x using a product identity. Number 9, if the cotangent of x is 12 over 5 and sine of x is 5 over 13, we want to figure out the cosine of x. And sine, we can put on our hexagon here, is 5 over 13. And then cotangent, we can put on a hexagon, is 12 over 5. And cosine, what we're looking for is a hinge with sine and cotangent. And those are our product identities we just talked about. So I can multiply together 12/5 times 5/13, and the 5s will cancel, and we'll be left with 12 over 13 as the cosine of x. Number 10, pi over 3 is a solution to the trig equation 2 cotangent of x sine of x equals 1. We want to figure out the second solution over the interval 0 to 2 pi. So if we want to solve this trig equation, we would divide both sides by 2, and then cotangent is here times the sine, which is here, that's equal to the cosine. So using the product identity, the cosine of x is equal to 1/2. So taking the inverse of both sides, x is the arc cosine of 1/2. So we're looking for our solutions in quadrant 1 and 4, right? That's where cosine is positive. Our quadrant 1 solution, if you remember our first quadrant left-hand trick, cosine is the x-coordinate at the angle, so that's the fingers on top. So we would bend this finger to get a 1 on top for the cosine of 1/2, and that's our pi over 3 answer. So our quadrant 1 solution, that's where this pi over 3 came from. The second solution, since cosine's positive in quadrant 4, is going to be here on our circle. And the whole circle is 6 pi over 3, that's 2 pi. So this would be 5 pi over 3 in quadrant 4. So our second solution is 5 pi over 3.